So what does redox have to do with anything? Well, it has a lot to do with displacement reactions, and in displacement reactions we studied in Chemistry 1, you should remember we typically associate them going to the prom. Single displacement reaction, you have someone going single, and then they meet up with a couple, and then they end up swapping dates, and one of that guy's kicked off single, and the other forms a new couple. In a double replacement or a double displacement reaction, the ions change partners. Okay, so you have two completely different, and we've already talked a little bit about these in terms of metathesis um, reactions. So in a displacement reaction, ions oxidize an element, and the ions then are themselves reduced. So what is oxidation? What is reduction? Well, if you lose an electron, you're being oxidized. If you gain an electron, you're being reduced. So I've got an example reaction here. We've got copper metal reacting with silver nitrate to produce silver ions and copper nitrate. Well, how do we know this is going to occur? Well, we have to look at our activity series, which we talked about last year. We're going to talk about here in just a second. But what happens, what's really happening here is copper is losing electrons, so it is being oxidized. Silver is gaining electrons, it is being reduced. Now, we typically say that silver is oxidizing the copper metal. Silver is oxidizing the copper metal because copper is losing the electrons, it is becoming oxidized. So the oxidizing agent, or the thing that is causing it to become oxidized, is the silver ion. Now, the reverse reaction will not occur. The silver will not replace the copper and go back the other way. Why is that? Well, it has to do with the activity series. And this is something that again, this is a big chapter on memorization. This is something that you must have memorized. Okay? Our more reactive elements are up top, our less reactive elements are down bottom. So our least reactive element work, doing gold and platinum, mercury, silver. So a lot of our precious metals that we make jewelry out of. Our most reactive metals are up top. So how does the activity series work? Well, any element can replace an element below it. So it can displace an element below it. For example, lithium can kick potassium. Lithium can kick anything out. Okay? But it cannot replace anything higher. Okay? For example, potassium cannot kick lithium out of solution. Barium cannot kick potassium or lithium out. Okay? So it cannot replace anything higher than it. But it can replace things that are lower. That determines whether or not a reaction will occur. Again, you need to commit the activity series to memory.